Hey, all you math Padawans out there. Today we are looking at similar figures. Is Darth Vader similar to Anakin? Let's go and find out. Here we go. Okay, today we are talking about similar figures. So we're talking about similar figures, and I'm going to go through a bunch of terms and symbols because you're going to find during your time with geometry, you're going to have to know some different things. So let's just go and, should I just go into, yeah, sure, for sure. So sometimes in math, and realize sometimes in math, we have different words for the same thing or different kind of symbols. You have to be a little bit flexible. So when we say similar, we often use this little wiggly thing. It's called a tilde. It's like on the upper left-hand corner of your keyboard. I've also seen some textbooks use 3 lines. There are some things that do that. So if something is similar, we can say that. So if I said like this happy face is similar to this happy face. Okay, that's how I would say it. And we'll talk about what that really means in a moment. So there's similar. What other kind of things do we need to know? We need to know this one, congruence. So congruence just basically means equal. And for that, something is congruent. We usually use like an equal sign with a little kind of similar thing on top of it. So that would be congruent. So sometimes we'll be saying, what would we say? We'll say like triangle. That's how we would say it. Triangle ABC is congruent to triangle DEF. This would be something you would see on a math textbook or a test or something like that. Definitely. And then there's the other ones, some different kinds of things. So we need to know what's the symbol for something that is perpendicular. So perpendicular. What kind of symbol do we use for this one? We use this. And notice when things are perpendicular, it means that it crosses at 90 degrees. And we also have, of course, parallel lines. So we have parallel. I'll put them the same color because they usually go hand in hand. Parallel lines, we will use this. So how would we go and do that? Oh, there's one other one I'm going to throw in here because I'm going to use that as an example. So the other one, let's get some green in here. Line segments. And again, this is just good knowledge for you to have. So line segments, we put a bar over top of letters. So I'm just going to put like over 2 letters, 2 random letters. We'll put a line segment like that. So let's just take a look at an example of those ones because I think that would be kind of helpful. So where's the example of the line segment's an easy one. So the line segment looks like this. So if I had a rectangle that looked like this, and I had A, B, C, and D, and I wanted to talk about the line segment like CD is equal to the line segment AB. So what does that mean? That just means basically that CD, which is this line, is equal to this line, AB. Cool, right? So that's how we start saying things. Whereas if you had, let's go back to the purple examples. So the purple examples, this is more, not too much to do with these lessons probably, but it's good to know. Let's say you had lines that looked like this. Like that. Yeah, let's say you had lines like that, and I'll call this A, B, C, D, E, and F. So I could say that, what could I say? I could say line AB. So line AB is perpendicular to line EF. And I just realized, of course, I put another symbol there, a little arrow going on top. So that means like line AB is perpendicular to line EF. So AB is perpendicular to EF. So see, it makes a 90-degree angle right there. Well, hypothetically, I'm saying it does. So you could do that. You could also say that, like line AB is parallel to, what do you think is going to be? Yeah, CD, you're right. Good job. Line CD. So there's some different words that you're going to be needing to know as we kind of talk about some different kind of shapes. And I thought it would be prudent to go and talk about those. Let's get into it though. We're talking about similarity. So what the heck is similarity? So what is something that is similar? So if something is similar, what are we going to say? It has the same, it's the same shape. And we would also say it's proportional. So you can see how it's kind of fitting in proportional ratios. So it's proportional. And for some shapes and that sort of thing, for most of the shapes, we're saying the angles are the same. Angles are equal. I'll just give you one little example of what I'm kind of talking about. So similar. So say we had this little triangle. These are triangles. And I'm just going to say like it's also similar to this. Okay, so it's the same shape. She normally it's number one. It's the same shape. We're not going to add in some numbers here, but I'm going to also let's add in some numbers to make it very obvious that it's proportional. And by proportional, what I'm meaning is the sides are proportional. So let's just say that you had a 2 here, and you had a, let's make it nice and easy, make this an 8. Okay, and say you had, I don't know, 4 here, and this was 16. Okay, this is kind of leading in today's lesson. So if you looked at that, if you had to go and compare like this to this, so I compared 2 to 8. Is that the same? Is it? Is it the same as a 4 to 16? Notice that I'm comparing now this to this. Is it the same? Well, remember, we can rewrite this. So this is using kind of your ratios and seeing if things is proportional. So let's take a look at it. So this would be 2 to 8. And is that going to be equal to 4 to 16? So if you set your kind of ratios up there, like, is it proportional? So hopefully remember how to cross multiply. So if you're cross multiplying, would they be equal? That's kind of the question, right? So here we're going to find that 32 is equal to 32. Yay! That's pretty neat, isn't it? Yes. And also, if you just take a look at the ratio, so kind of going into this. So if I asked you what's the ratio, kind of like what's everything kind of going by, it would be 1 to 4. 1 to 4, and they're both in a 1 to 4 ratio, aren't they? How do we see that? Well, if you take a look at the 2 to 8, so that 2 to 8, maybe I can just go like vroom. So 2 to 8, that of course would be 1 to 4, right? If you simplified it, and if you had 4 to 16, that's a 6. Really is. That would also be 1 to 4. Like that kind of stuff, okay? So yeah, so that is similar shapes. So same shape, proportional, and the angles are equal, which we don't really kind of focus on too much of that, but do realize that they are. All right, I want to get into some examples about similar figures, because that is today's topic, is looking at that. So let's get into some examples to see if things are going to be similar. So are they similar? So how do we do it? So step one is always kind of a weird one that I talk about. So step one, and this all depends on, I don't know, if you have like those tricky math teachers out there, sometimes they'll do this, is making sure the shapes line up properly. So make sure that the shapes line up. And what do I mean by that? This is what I mean, is that, let's say you had a triangle like this, and you had a triangle like this. Whoa, okay. So notice that you have to do a little bit of rotating to make this happen. And depending on what the letters are. So, you know, if I rotated that one down, then all of a sudden it's like, oh, okay, so it looks like that. But you have to really make sure that all the sides are lining up according to what the question would ask. Let's see an example of what I mean by that one. Okay, and we'll do an example in there. So once you do that one, and then we'll do an example with that. But step 2 is going to be create a proportion. And then, of course, solve it, right? Solve it. And again, if something is proportional, if they're equal, then you can say that they, if the objects or the shapes are going to be similar. So, how can we do this? Let's do a little bit of example of that one to get you guys going. Here we go. I'm going to give you a triangle, because triangles are awesome. And I'm going to say this triangle is ABC. Very, so far, pretty fancy, right? And I'm going to say you have another triangle here. So, and nothing is drawn to scale because, let's be honest, I can't draw very well. Although I'm trying to work on it. There we go. X, Y, Z. Okay. And my question, of course, and let's add some numbers in. I just want to go and find out missing sides. So I'm telling you, ABC is similar. So triangle, ABC, I'm telling you this. ABC is similar to XYZ. Okay, I'm telling you that. That's very exciting. And I'm going to give some different kind of things here. I'm going to try and find what's another letter. Let's go and find what D is. So this is D, and this is 3, and this is 4. And over here, between Z and Y, I'll say this is 6, and X, between X and Y, it's going to be 8. And I'll say this is, I don't know, F. And I'll say and go and follow those ones. So a few things here is that we have to kind of do a little bit of rotating. So I'm going to do a little bit of rotating. So that's what I was talking about up here. So I want to go and rotate this one so it matches. Use a different color. So it looks pretty. So I want to go and rotate this triangle. So I want this triangle to say X over here, Y, and Z. Why do I want to do that? Well, here's the thing. This is why I want to do this. Because if we're saying these are similar, that means A matches with X, B matches with Y, and C matches with Z. That's what we're saying here. Okay, so I'm just going to do a little rotation here. I find this is really helpful for kids. I'm going to fill in the numbers again. So what I always kind of do if I was a kid, so it's like, okay, so what's happened here? Between X and Y was an 8. So between X and Y here, it's going to be an 8. There you go. And between Z and Y was a 6. And of course that leaves you with an F there. I find this makes it very, very easy for kids to be able to compare things. So that's my little tip. And I've been doing math for a little bit, so you should probably figure some things out that, hey, maybe he knows what he's talking about. Okay, we're going to find it first. Let's go and find out what D is first. Let's go and find out what D is. That sounds like fun. So I'm going to compare A to B. So I'm going to compare AB, line segment AB. I'm going to compare that to BC. So I'm going to compare that to line segment BC. Different ways you can do this one. And I'm going to make these, because this is similar. So AB, what's the one over in AB? It's going to be line segment XY compared to line segment YZ, right? And that's what we're basically doing. I just want to get you familiar with some of the nomenclature. That's a big word, nomenclature. Let's go and fill in the numbers now, right? So line segment AB was D, and BC was 4. So we're comparing these, like, so this is being very deliberate in how we're comparing. And this is going to be 8 to 6. So far, so good. Sweet. Now this one, maybe it's a little more complicated to go and solve. So you're going to go and cross multiply. So hopefully it isn't too bad. So you're going to cross multiply like this. And what you are going to go and get is d times 6. So I'm going to say 6d. And that's going to be equal to 4 times 8, which is going to be 32. Now you can see already that you're going to have a little bit of dividing. You're not going to get a super pretty number. But that's okay. You're going to divide by 6. And you're going to find out what d is equal to. So d is going to be equal to, what's that, 5 something? 5 1/3. So depending on your teacher, you would say 16 over 3. Some teachers might like 5 1/3, or there's some crazy teachers out there that would say 5.3 repeating. I'll give you all different teacher answers, okay? So that's what you're doing there. So you can go and kind of plug that in. That's pretty exciting. And yeah, that's kind of what you're doing there, aren't you? Pretty straightforward. So now you know what D is. Yay. If you want to go and figure out what the F is, I'm running out of space here. Where can I do the F one? I should really get a... Is there a easier way to erase this? There must be, right? This doesn't seem like a very good way to erase. So here we go. We're going to look at F now. So we're going to say this. We're going to say F is to 3. So this side F is to 3 is equal to 6 is to 4. Like that. And a couple things I want you to try to take a look at is, what does the F and the 6 have to represent? This is the big triangle, and this one is the small one, right? Notice what I did over here. I said D over 4, so this is how I grouped them over here. I said this was the small triangle, and this was the big triangle. But, so many colors, I kept those things similar and these things similar. So as long as you're being very consistent, you can do kind of your cross multiplying. So I'm going to cross multiply here, and I get 4F is equal to 18. So 4F is equal to 18. Divide both sides by 4, and you get, depending on how, again, teachers, you're always going to have different answers. But basically F is 4.5, 4.5. Maybe somebody says 9 over 2, somebody says, I don't know, 4 1/2. It's 4.5. I can write that, and you can probably be figuring that out, right? So that's how we're kind of going and comparing. So as long as we're comparing the same things and setting up our proportions, we can figure everything out. That got really messy, didn't it? Sorry. Sometimes math just gets messy. Just gets messy. Let's do another example. Let's do this one. I like this one. This is kind of the level that I expect my students, students who've been in my class. So I'm saying these are similar. So I'm telling you they're similar. I'm even drawing them so that they are similar. And I'm saying this is 2x plus 9 over 2. So here we go. This is going to be some fun stuff. So we're going to do some comparing, right? So we're comparing this to this, yeah? And we're also comparing this to this. Hypothetically, if these are similar, they should all work out quite nicely. So here we go. This is what it looks like. So I'm going to say 2 is to 7. So I'm comparing 2 to 7. So I'm always starting with the small one and then putting the big one on the bottom. So over here, I need to put the small one, which is going to be x, and the big one on the bottom, which is 2x plus, can I change 9.5. I'm going to change it to 4.5. Don't be freaked out by that. Okay, so what does the math look like? We're going to cross multiply. And if you are still wondering about how to do that, check out my other videos on the distributive property. I think if you do some searching, you can probably go and find stuff. But remember, when you're distributing against both things inside the brackets, so don't forget that. So you end up getting 4x plus, what's 2 times 4.5? Oh, 9. Yeah. Is equal to 7x. And what I always like to do when I'm doing my math is I take a look at which side, so remember we have two sides to the equation, right? Which side has more x's? The right side does. So I'm going to keep my x's on the right-hand side. Oh, it's crazy, I know. You don't have to do that, but it's going to keep things a little bit more straightforward, perhaps, or not. I don't know. It's up to you. Anyways, you get 9 equals 3x. I'm trying to fit this in really small. How do I get x all by itself? I divide both sides by 3. By 3. Yeah. There we go. Woo. And x is equal to 3. Yay. And there you go. Cool. So that's a nice little similar one. And now a couple of other things that another example I want to show is when you have triangles within triangles. So triangles within triangles, they are going to be similar. And so I put a little star here. This is a good example that I'm hoping you're kind of looking at and you're really taking to heart. So here we go. So I'm going to do this. And watch what I'm going to do. I'm going to draw this line here. And basically I'm saying that these are parallel. So remember these little symbols? That means like that means that they are parallel. And I'm going to call this triangle A, B, and C, the big one, A, B, C. But I'm also going to have a little tiny one called C, D, and E. This is so cool. And then I'm going to go and add in some numbers. I'm going to say this is 5. I'll say this part here is 7. And that only goes from here to here. Okay, just to be clear. And I'll say this is 15. Now, we're saying that these are going to be similar. Similar. So what do? You must draw both, okay? You really need to draw both. Now, I know some students are like, what? So I'm going to go and draw both. So we have the small little triangle. We have the tiny little one like this. I'm going to keep things all nice and looking nice. So it's D, E, C. Cool. And then we've got the big one. Like this, the big one. And this is A, B, C. Let's go and plug in the numbers. So go over here. I guess D, E was 5, right? D, E was 5. And E, C was 7. Cool. And then AB was 15. Nice. Now, what are we trying to find? We can find so many different things here. What do we want to find? I don't know. Let's go and find what would be fun. Let's go and find this part right here, BE. Let's go and find BE. So what is line segment BE? What's it worth? What's it going to be worth? Okay, so any ideas on how we can go and do this? So obviously, if you knew what BC was, if you figured out what this is, you could go and subtract EC and figure out BE. So you got that? Yeah? Does that sound right? Let's go and do it. So I'm going to compare 5 to 15. So I'm going to compare 5 is to 15 as 7 is to this random x. Yeah, that's what I'm going to go and do. I'm going to go and cross multiply and solve. So I'm going to cross multiply here. I'm going to say, what's that? 5x equals 7 times 15. What's that? 70? 105? Is that right? 15 times 7? 70 and 35? Yeah. That means x is going to be 21. Cool. So now I know that this, BC, I know that this is 21. That makes me super excited. Because if this entire line here is 21, and this little piece is 7, to figure out BE, I need to go 21 minus 7, which is going to be, boom, 14. Oh yeah, there you go. All right, all you math Padawans out there, hopefully you understood what similar figures are. Until next time, have a great day.